Okay, yeah, we're live. Here we go. Good afternoon, everyone. My name is Jim Manico, and I want to talk to you about secure coding. I want to talk to you about your responsibility as a developer to write secure software. And this responsibility is unfortunately mammothly challenging. Who here works in an organization or works on a project where security is a really core part of your development process, where it's really what you're doing? And that's like 5 of you. Hey, 5 people. High five to you 5 people in the room, like 1% who security is a core part of what you're doing. The rest of you, I don't know. We're in 2020. Check the news out. Software is getting hacked on a daily basis. It's one of the most destructive things happening in modern society, even worse than the global illegal drug trade in terms of how much damage is done to society because of our inability to write secure software. And I'm not here to blame you as a developer. Hey, the languages, the frameworks, everything that we're doing by default, the web, the standards, is relatively insecure. So there's this challenge, responsibility to write secure software is an immensely difficult one. But we can do it with the right knowledge, with the right engineering practices, we can do this. Now, this project I'm going to talk to you about, this awareness list, is from the OWASP Foundation. And I want to put OWASP on your radar if you hadn't heard of it already. OWASP is the Open Web Application Security Project. In the US, it's a 501c3 formal charity. It's also a recognized, registered charity in Europe. In the US, to become a charity, we fill one form out and we're a charity. In Europe, we fill out about 5,000 pages documents in triplicate, and then you got to name your child Europe. It's kind of tough to become a charity in Europe, just a paperwork burden. So we're a real charity around the world. We're very similar to the Apache Foundation, right? We're trying to promote web security standards. We're trying to promote secure coding best practices. And there's a variety of tools from the OWASP Foundation that are all open source. The big one I'm going to talk to you about is OWASP Zap. This is a penetration testing tool that you can point at your web apps to do scanning to look for vulnerabilities. In the commercial industry, these tools range from 1,000 to 100,000 euros, and OWASP has several free tools in this area to help you look at your applications for secure software. But that's the hacking part of security. That's easy. We're going to talk about doing it proactively, which means early on in your software development lifecycle, you should be thinking about security. Hey, sir, what's your name? Up front. Yeah, hey. Yeah. When in SDLC should you be thinking about security? When do you think? How about like when the project's done, let's slap some security on at the end? Is that the way to go? Right at the beginning, from the design phase. The earlier you address security, the cheaper it's going to be for your organization, and more effective it's going to be. So this is the OWASP Top 10 Practical Controls. We'll talk about security requirements. We'll talk about the importance of the frameworks you're using and third-party library responsibility. We'll look at briefly database access and SQL injection. We'll talk about encoding and escaping as a core control to stop injection. We'll look at input validation, some specialized form of it you got to get right. We'll look at the whole idea of digital identity and how complex it's gotten. We'll talk about access control, protection of data in transit and storage. We'll look at the idea of how important logging is and error handling to end. These are in this presentation. If you're advanced at secure coding, you're excused. There's other talks you can go to. This is meant to be an introduction to get you started and point you in the right direction of your studies for how to be a software engineer that does security engineer. And again, my name is Jim Manico. You can find me on Twitter at Manicode. Please tweet me up. I'm a former board member of the OWASP Foundation. I'm also a board member of SecApp Dev in Belgium. This is like a full-week secure coding course. I founded the Local Moco Security Conference in Hawaii. It's a product security conference. And we don't do this conference to make money. We do it to spread this knowledge throughout the Hawaiian Islands. And we're stoked to see, like, Google sent like 50 people. We're excited. There are very few product security conferences out there. It's a big deal for me. So I founded several of these projects. We're going to look at the cheat sheet series, the proactive controls, the OWASP Top 10. I'm a part of those projects. Wrote a book. Been coding my whole life. And I'm from Hawaii and from Virginia. Let's get started, though. Step number 1, in any secure coding program or application security program, let's define security requirements. Who here is agile? Who does agile development? Who does agile? Okay, how many of you do agile by name? Raise your hand. How many of you actually are agile, like you're pushing code live many times a day kind of agility? Now, those of you who can push code many times a day, live, production quality, fast pushes, you're now doing like continuous integration and development. You're doing automation. You're pushing code live many times a day. You're agile. Who here can only push code once a month because of technology burden, yet still call themselves agile? You are not agile at all. You're far from agile. You're using the name, but the modern definition of agile is really in the world of DevOps, where we're pushing code many times a day through automation. Everything else is not agile. So in this world of agile, requirements go away. Like formal documented requirements are a thing of the past. And this is bad for security. How many of you, like the main standard document for security requirements is the ASVS standard, 280 plus requirements we have to master. And very few of us have that level of mastery. I don't say this in an arrogant way. It's just that we have other things to do as developers, like get the freaking app to even work, let alone take care of the rigorous job of doing it in a secure fashion. Every SDLC document I've ever looked at, the Microsoft waterfall process, here's some SDLC lifecycle document, here's the agile Microsoft documentation. Every single doc they say security requirements is a core part of a secure SDLC. I want to introduce you to the application security verification standard. What's your name, sir? You came to listen to a talk, right? No, it's not just listen to a talk. You got homework from this. This is a homework-based talk. So when you get back home, you've got to read this document, and we'll be watching, Mark. We'll be watching you, Mark. So I ask you all to go read this standard, right? This defines 3 risk levels, over 200 controls. It's similar to ISO 27034, but with a lot more tactical detail. A lot of the standards around software security, they're very high level and philosophical. And we're not philosophers, we're scientists. So we need real tactical advice to do security. This is where ASVS shows up. It is a publicly built standard. It's a lot of the standards I've seen in the world are built behind the scenes in a secret cabal with secret handshakes. This is all done in public on GitHub, and a lot of anonymous people provided comments that drove this standard. And there's 3 levels of severity, 3 levels of risk for each individual requirement. Level 1 is for every single app on the web. Level 2 is for high-risk, financial, sensitive data kind of apps. Level 3 is if you're like storing billions of personal records or infrastructure for your government or building something that shoots missiles. That kind of needs level 3 at that point, right? And so all I'm trying to say is that you're probably on a team where not everyone understands how to write secure code. And that's the status of the world today. I highly recommend you go grab the ASVS standard. Grab that requirement list and fork it to suit your company. And now you have an initial secure coding standard. I think a good place to start, grab the level 1 requirements, fork it for your company, and make sure the developers have the final say in which requirements matter. And now we have a baseline of what security means. Like right now when I ask most people, what is security? I get these philosophical answers. The app should only do what the app was meant to do. Oh, the app should not be able to be hacked. And as a developer, that does nothing to help me write secure software. It just pisses me off, right? But when I say verify that least privilege exists, users should only be able to access functions, data files, URLs, etc., for which they possess specific authorization rules. I can act on that in some way. So these requirements all are going to give you really tactical advice on how to do secure coding, and it's a great place to start. What it gives you is, it gives you a common definition across your teams of what security is, from design to implementers to QA to security testers to operations. Now all of us who want security all have this, we're all on the same page around what that means when we care enough to use security requirements, not just to build the list, but actually use them in our jobs day to day. All right, we're talking about the OWASP proactive controls. Sir, you're late. This is the OWASP proactive controls. You already missed number 1. It's requirements. It's okay. Thank you for being here. We're now at number 2. Number 2, create security frameworks and libraries. So leverage security frameworks and libraries. There's a lot of security controls we have to build today. We have to build authentication layers. We're going to build cryptographic solutions, get TLS running for transport security. We need to do escaping, HTML sanitization, all these different controls core to a piece of secure software. And you shouldn't be writing this stuff yourself. We want to use a variety of open source tooling out there. For example, Apache Shiro does really good access control type of work. In the world of .NET, we have the HTML sanitizer, a NuGet from NGANS, which is critical for HTML sanitization, which I'll talk about a little bit later. So I just want you to use a variety of open source security libraries that are well vetted, that have been built, reviewed, and serve a core purpose in providing security. And more importantly, once you grab a third-party library, you just picked up massive responsibility. What is that? When you're doing secure software and your team chooses to use third-party libraries, the moment you start picking up third-party libraries, there is a massive responsibility attached to it. Oh, great bearded one who's nodding. What is that responsibility, sir?
To check the security of this library.
Yes! Check the security of the library to make sure there's known security vulnerability in it. And anyone know what major hacking incident happened in the US because of third-party library insecurity? Yeah, do you know how like half of the UK's financial records got leaked because of a US company getting breached? Did you give Equifax permission to store all your financial records? Probably not UK citizens, right? But yes. So the Equifax breach definitely affected your country a great deal. This is one of the largest financial leakages of data in the history of our planet. This is a big deal. And first of all, when I was writing code, the last big project I did a few years ago, this is the vulnerabilities that showed up through my project. The first one's XXE. Anyone ever heard of XXE before? Who here is shilling XML? Who here accepts XML to their web services? Who here accepts XML in their legacy XML, in their legacy API services that you're not working on anymore? Now we got some hands, right? And so I can send one piece of XML to your server that uses an entity that refers to an external reference, like a file on your operating system. And in one shot, if you're vulnerable to XXE, one request, I have your password file off your Unix machine or your IIS machine or similar. In the world of .NET, since 3.5 and above, this has been turned off by default. But this is a prolific problem in software across the world today. And so this is what the vulnerability in Struts 2 not too long ago led to the hack at Equifax. And Equifax actually did a pretty good job. They patched the majority of their servers. It's one cluster of servers that was not patched that led to an entry point into Equifax's network, which gave them months to look at the systems internally. After 2 months of looking, they found the actual financial records and spent 3 months stealing those records before they were caught. Anyone know how the attack at Equifax was actually caught? Equifax was using a data protection piece of software that was inspecting the network looking for security issues. And this is a device that is an interceptor of transport security. It has certificates built into it and on clients of the people in the company, so it can inspect encrypted traffic, HTTPS and TLS traffic. But someone didn't update the certificate in this product at the beginning of the year. And so it was running saying everything's good, and yet it wasn't seeing anything. And then when some low-level engineer said, hey, this $10 million product is not working because the cert's not up to date. So they updated the cert, and all of a sudden they see like all the financial records of the world being stolen in progress, and they shut it down. This is when we go back, when we're further in history, when our kids are going through school learning about security, we're going to talk about this incident as being a change, a paradigm change so dramatic that it's going to lead to a lot of big changes across the world. And it just shows that one server not being patched can lead to a global, pretty nasty incident. When you're using third-party libraries, you have got the responsibility I'm looking at, oh great bearded one, is we've got to check our software stack every single day to see if all the third-party libraries we're using have a known security bug against them or not. And there's tooling in the world. There's a lot of commercial tools. I'm not going to talk about those right now. From the OWASP Foundation, we have the OWASP dependency check product. And there's also RetireNet from the open source world that you can point at your .NET applications to check if any of your third-party libraries have a known vulnerability in them. How often should you run this tool to check your project for insecure third-party libraries? How often should you run this?
Every time when I draw new, when I deploy before.
Before each deploy?
Yeah.
I like that. Who else wants to play? That's a good answer. That's reasonable. By the way, when Apache patched this Equifax vulnerability, how long did it take before Equifax was breached? It was 72 hours. Ooh, 72 hours. Who here has a process where you're updating your third-party libraries within 72 hours? That'd be nobody, not even my teams. But this is the era we're in right now. So I recommend that during building, you check your software for third-party libraries every single time someone touches code. If I start to build it, let's go run that tool and go check. Let's check it at night when everyone's asleep. Let's check it every time someone touches code. And you know what, people, even the best teams out there who use these tools, they're not touching their legacy software with this. So I recommend you onboard your legacy software that you're not working on anymore and run that every day to check for third-party library insecurity. In my mind, insecure third-party libraries is the #1 issue in application security today. A lot of commercial tools that address this as well. There's also a great lad from Norway, Erlend Oftal, who wrote retire.js. This is scary. This is a plugin to Chrome and other browsers that on any single page you're looking at on the web will tell you if they're using insecure third-party libraries. It just, before you load this tool up and use it, steel yourself. As you go to your government websites, your banks, the most secure sites in the world, you're going to see that they are lit up with insecure JavaScript. I personally think JavaScript is a filthy language that no one should use for any reason, but let's move on. Let's move on. All right, that ship has sailed a long time ago. JavaScript ain't going anywhere. Some of us, what's your name, sir? Sergey. You're not going to believe this. Sergey? Not even close. Sorry. So whatever you just said, right? Sam. Hey, Sam. I forgot what I was going to say. Do you know what some people are doing? You're not going to believe this. You ready? They're using JavaScript on the server to build APIs with. Oh my God. What's that? I heard of that. Yeah, let's just move on. Let's move on. I'm sorry about that. So check your code. Use some kind of open source scanner or commercial scanner to check your code base as many times as you can per day to make sure your third-party libraries are up to date from a security point of view. Right, we're looking at the OWASP Top 10 Proactive Controls, an open source awareness project. Let's look at the third item about securing database access. So how's this for a great password? It's uppercase, it's lowercase, it's number, it's got some special characters, it's over 16 characters. This is like a great password, doesn't it? How about this? What's that? Here's the perfect email address. Jim, single quote or single quote, one single quote, not equals, single quote, at manico.com. First of all, is this a real email address? Am I just pulling your leg here? Do you think this is a real email address? What do you think, sir? You, right? You, with the orange shirt. Good color choice. I like orange. Yes, you. Is that a real? Could be. That's a good political answer. I love it. It could be, sir. No, cheers to you. Anyone who wants to play? You think this is a real email address, or am I just pulling your leg? Yes. What's that? Yes. You know what? Yes. Okay. Here's this. Not only is this a valid email address, guess which other wonderful property it has? It's live right now. It's one of my email addresses. This is my domain. So if you're like, I don't believe you, go ahead, send me an email. Say, is this real? I will answer with one word only. I'll respond and I'll say, believe. It's real. There's a real email address. So how do you stop SQL injection? A lot of people tell me it's sanitizing or input validation. If you run a validator against this email address as part of your security code, and you ask the question, is this a valid email address? You do that, a lot of people do that for security. What would that validator say? What do you think, Sam? It's going to say true. It's a completely RFC compliant email address. It's live. It's also compliant against the regular expression for email addresses defined in the HTML5 standard. So this is a real legit email address. Now, if all you do for security is only to validate this email address, and I'll do something like this. Here's a database query just to look up a record. And here's my lovely, valid, legal, RFC compliant, and live email address right now. There's the final query. Hey, late guy. Hey, what's your name, late guy? Yeah, it's you. You're late guy. It's okay to be late. I'm here for you. You're not here for me.
Halil.
What's that?
Halil.
Halid? Halil. Yeah. Okay. What does this last query do? If you see that or one does not equal manicode.com, what is that? Are you a SQL guy? Yeah. What is that? What does that last clause say? Or true. When you add an or true at the end of Boolean logic, what happens to that whole statement? So whenever I'm asking, can I select data from this table every single row? The answer is true. And now with my email address, I can steal all data from that table. So this is a way we steal data by manipulating SQL queries called SQL injection. Anyone know how do you stop this problem? How do you stop SQL? Just shout it out. I am uncouth, American, rude, and lewd. I try not to be, but let's be truthful. So just go for it. Use a parameterized query. And by the way, you can use a parameterized query interface and still have SQL injection if you don't bind your variables. So you want to use a parameterized query interface, and every single variable you add to your query should use parameter binding. Just like this down here. And who cares about Java? You want to see .NET? You're all .NETers, right? I'm going to go off the rails for a second here. Let me see if I can do this quickly. So I'm going to go to SQL injection. So my other presentations, please forgive me. I want to show you the right answer from a .NET point of view. You're all .NETers, right? I didn't even know that until really recently. So where is that? Where's that? .NET. Oh yeah, and that ASP. Who cares about ASP? Anyone doing ASP still? There you go. Here's parameterized queries in the world of .NET, right? We have the SQL command class. Notice my query is one string. The moment I see a query that's built using string building, that's usually the symptom or weakness that will point me towards SQL injection. So note here, there's no string building. It's one static string to define my query with an @name and @password as my placeholder. I then bind any old untrusted data into that placeholder. SQL injection goes away. This is because you're going to tell the database to build a query plan before you send data to that plan. In normal SQL injection, I manipulate the query. I change the query string, which then gets compiled, and the database just runs it. If I parameterize my query, the database will compile, essentially, the placeholder query, and then we send data into that query plan that's already constructed, and SQL injection goes away, and the performance of your apps goes up significantly because this compiled query is cached at the connection level. We have the same control in every other major language. Let's go back to our main presentation here, though. All right. Be careful about one thing, though. You can't parameterize every variable. Look at the table name here. See how the table name is a parameter? If your table name is a parameter, what does that imply about the design of your code? What do you think? If your table name is a parameter, what's the implication here about your code design? That you're taking a table name as user input? Hey, Mark, what do you think about taking a table name as user input? How does that make you feel, Mark? Uncomfortable. A bit uncomfortable, myself as well. What about the order by clause being a column name? Is that acceptable? I think so. I do that all the time. You can't always parameterize a column name, and yet we need to for like doing sorting. If I have a table of results and I'm sorting it and I want to redo that query, order by a column name is pretty common. I want to make sure, I usually do exact match validation on a feature by feature level. I want to be able to order by a list of different column names. I want to make sure the column name is only one of the names I expect. And even better, at the UI level, I'll use a number for sorting, which maps to the internal column name, never exposing my database internals to the client in any way. That respects one of the original object-oriented patterns called the data access object, DAO or DAO, data access object pattern, one of the earlier OO patterns about building MVC software. All right, so one SQL injection using something called a timing attack I can use to steal your entire database. So we got to take this stuff seriously. Here's some additional resources, and here's some additional resources and how to do query parameterization in a plethora of modern languages. OWASP top 10 number 4, we want to encode and escape data. In the user interface, if a user interface on the web sees this character, it thinks it's code. I'm starting a tag here. And if I escape it, &LT semicolon, it will display the less than symbol as an HTML entity without being code. This is meant to stop cross-site scripting, where the attacker can insert data into your application that includes a JavaScript snippet that another user will look at, then I, as the attacker, can inject JavaScript into your application that someone else looks at. Hey, Robin, is this dangerous? Yes, it is. Can you get, in this example, look what I'm doing here. This is an attack, right? In this attack, where's the mouse? Mouse. There it is. In this attack, I'm popping a script, has a URL to an evil website, and grabs a copy of your cookie. We build an image in JavaScript and then say image.source, which will make a GET request to load the image, and then actually it's going to send a copy of your cookie, the victim's cookie, to my server, which I can use to hijack that account. So this is just one example of cross-site scripting. With evil JavaScript, I can steal your keystrokes, deface the whole site, steal any data from your page, and even worse, I can force you to make any verb request I want. Get, post, put, patch, doesn't matter. That's called a stored request forgery. So this is a really big problem. The way we solve it is we escape. If you're doing old school templating in the world of .NET, I recommend you use the anti-XSS library to do contextual escaping. And this is pretty brilliant. It has escaping functions for all these different slots in a web page. There's a lot of good knowledge about this as well. Who here is still doing old school templates for their HTML construction? Who's doing Angular or React or Vue or something more modern? Like 5 of you raised your, who's doing, what else are you doing? You're not using templates, you're not using JavaScript clients, what else are you doing? We do like native web code or some crazy stuff like that, or? Backend. Oh, you're not doing UI stuff. Oh, you got other people for that. Oh, I see how you roll, I see how you roll, okay. So we have the same kind of, so there's an encoding escaping library for every major language on the planet. The goal is, before I ever put a piece of data into a user interface, if I want to display that data exactly like user typed it in, I want to escape it in the right context of the location on the page. Is it an HTML block? Is it in a JavaScript snippet embedded in my page? Is it a URL? Each of those needs a different form of escaping, and that's what this family of escaping libraries is for. And just one more note, cross-site scripting is actually much more complex than that. This JavaScript UI injection type of attack. I want to escape. I want to avoid JavaScript URLs from user input. I want to make sure I sanitize when I let users author HTML, and much more, right? And so there's even other forms of injection, like command injection. That's an operating system command being run through your software maliciously by an attacker. There's some resources there. And all these, I have a lot of links. The goal is for you to like go grab this presentation and read these resources. So I'll make sure I publish this presentation out today. Check, in fact, I'll tweet it out over at Manico if you want to grab a copy of this. So go check my Twitter feed a little bit later today. OWASP top 10, we're now at number 5. Hey, what time am I supposed to end, by the way? Those of you who are meticulous about time. 4, oh, I got plenty of time. All right, we're halfway through. Input validation. Now, we all know about basic input validation. What does that mean to you? If I say you should validate input, what does that mean to you from a technical, tactical point of view? Validate your input. What does that mean? Anyone? What about Mr. API developer? Do you validate your input on the API side of the house? Yes. What does that mean, though? What kind of technology are you using to do input validation?
Well, it's a combination of type safety and
type-safety,
semantic, like allowed values for a certain type.
The common technology that most of us use to do input validation is a regular expression, right? For every single input, we typically build a regular expression that defines what good data is and automatically reject everything else. This is called whitelist positive validation. Like if I'm expecting an 8-digit number for something, then I look for that 8 numeric digits and reject everything else automatically. This is not perfect security. Remember, my valid email address is still SQL injection. protection. But input validation is a really common defense technique. It's been built into .NET natively since version 1.0, so we at least have it there. But there's a certain situation where traditional input validation falls apart. Anybody, do you ever allow users to submit HTML tags in their input for any of your applications? Again, the question is, when users submit input to your application, comments, blog posts, anything, do you ever allow users to give you HTML tags in their content? You say yes. Anyone else? You say yes. How do you ensure that that HTML is secure, that doesn't contain evil JavaScript, or doesn't contain any JavaScript, frankly? You want to use it's right up on screen. Use an HTML sanitizer. And here's the sad story. There's no good HTML sanitizer in the world of .NET. There's not. There's one NuGet, right? It's from Ngantz, who supports the HTML sanitizer. He forked this Java project written by a Google engineer. So I personally know bypasses against that library to this day. This makes me kind of nervous, to be honest with you. But we do have basically, you build a policy, you define what tags are good, and everything else is going to be rejected. I've been watching this library. I'm sorry, let me say that again. The sanitizer really has a hard time telling if HTML is secure or not. But it is easy to clean things up. So we define the rule system, we shove HTML into it, whatever comes out of it will only include the tags that we defined. This problem is brutally difficult. The person who wrote this library, Michael Samuel from Google, one of the best security engineers I know, it's had multiple bypasses against it. We fix it, but I have to parse HTML5 in a rigorous way. That's a brutally difficult problem. So all the server-side sanitizers have security histories against them. Again, the user submits HTML as input to my server. I run it through this sanitizer, and what comes out, I should be able to safely display to other users. We have a bad history of getting this right on the server. What I recommend is you do it on the server, but also do it on the client. Introducing DOM Purify. This is a JavaScript library that frankly helps protect the home page of the whole web, Google search engine. I know you may not like Google because of privacy issues. I agree. I struggle with Google as a business. There's actually antitrust things going against it right now. But the people who work for Google, Mike West, Mike Samuel, Michel Spagnuolo, Lucas Schweich, these are some of the best security web engineers on the planet, and their work serves all of us. I'm a big fan of what comes out of it, what comes out of their work. Now, this library in particular is written by Mario Heydrich from Germany, from the Cure 53 team. And this is a brilliant library with a really solid security history. Anybody here use React in their work? Any React developers? Like a few of you. Ever hear of that function, dangerously set inner HTML? What does that function do? Yeah, it disables the React's escaping and puts HTML raw on a page. So React developers, if you're using the function dangerously set inner HTML, what kind of life are you living, may I ask? How are you living? You're living dangerously. Are you with me? Anytime you use dangerously set inner HTML, before you do that, run your content through dompurify.sanitize. You don't even need to configure this library. It has a really safe subset, or safe default policy around what tags are okay and what's not. HTML comes in, you sanitize it, and now you can drop the results of that library into inner HTML or drop it live on the page. So for both Vue and React, failed to do HTML sanitizing in their library. Their answer is, here's how you turn off our security, and now how to sanitize HTML, that's your problem, good luck. And that's irresponsible from a library point of view. You look at Angular, I wouldn't wish that on my worst enemy. It's too complex to maintain, in my opinion. But they have the security built in really well. This is built into Angular. Same team who wrote DOM Purify also wrote Google Sanitizer. And so we need the sanitizer for almost every major language. Again, the sanitizer in .NET, I don't think it's as rigorous as it should be, and I don't know of anything else to recommend for .NET. You're a .NET shop here. Does anyone know of an HTML sanitizer in .NET that's well maintained and rigorous beyond this tool here? I don't know of one, and I keep looking for it. Who's the head of security for .NET? Some Barry guy. Barry Dorns. Oh, I love Barry Dorns. So I was just curious one day, and I went and tweeted out Barry Dorns. I'm like, hey, Barry, what HTML sanitizer should I recommend for the .NET community? And he starts attacking me on Twitter. I caught him on a bad day or something, and I'm kind of a jerk. It's okay. So Barry starts going after me. Because the default sanitizer in .NET from the anti-XSS library, they neutered it so it would be secure, but it's unfunctional. Sports like 10 tags and it's done. And there is no good library out there. And it takes a team of people to make these sanitizers work well. So again, I think the answer here is DOM Purify on the client and the HTML sanitizer from Gantz on the server. It's a hard problem. To bypass both sanitizers, not likely. All right. So the other big problem in validation is doing file upload security. Anybody ever take images from users as an upload feature? How do you make sure you're not being attacked by those images? There's a whole class of attacks where I can build a GIF that if you upload to your server and make it accessible, I can point to that GIF with an OS command and run OS commands against your server called a GIF shell. There's WMF files back in the day from Microsoft. And so there are ways to, if you're poorly validating images, I can attack you through an uploaded image. So how do you lock this down? I usually use a tool called Image Magic and use a technique called image rewriting. When a user uploads an image to me, I'm like, whoa, this is an easy way to attack me. So I run it through Image Magic, change it by 1 pixel, and save it. Image Magic is a C-level image manipulation library. So if I can load the image, change it by a pixel, and save it, and all 3 of those operations work, it's a legit image. Then I'll throw away the original and use the one that came out of Image Magic just to make sure that the image is legal. And in general, validating complex file types like Microsoft Office files is a real tough problem. How do you validate that an Office file is legit? Anyone know how to do that? What kind of file is a Microsoft Office file? What kind of file is it? Just XML. Just XML. .xls. Just L is a big chunk of XML. The schema for that XML is like 500 pages long. It's a complicated piece of XML. Am I correct? Microsoft files are just XML. Everybody with me on that? So if someone uploads like an Excel spreadsheet or similar to your server, how do you make sure it's a real Excel spreadsheet? Or even better, how do you ensure it's a real Excel spreadsheet without a macro that will do something dangerous? Can I do something dangerous in an Excel macro? Yeah, I could steal all data off your machine, game over. So it's really dangerous. So how do you upload an Excel spreadsheet that you're gonna operate on or save or distribute that's secure? I don't know the answer to this. I literally don't know the answer to this question. I don't think anyone does. It's too complicated of a file format. So what I see a lot of people do is they take it and before they distribute it, they say, hey, good luck, this might be insecure. Or they just take it blindly, check the file name. Oh, it's XLS, it must be good, or something like that. So this is a real hard problem. In the world of Java, I use Apache Poi to programmatically look at Office files. And that's usually a few versions behind the 8-ball. I don't know what to do in the world of .NET at all. And no .NET architect has told me what to do either. Just proceed with caution. This is a very dangerous feature that is really hard to lock down. And again, don't forget, even validating can cause injection. Input validation is not going to save you. We're now looking at the 6th proactive control that you should be aware of as a developer, the whole concept of digital identity. And so this is a great moment in my career. Here I am in London. Let's talk about US government identity standards for a second. And I'm not expecting you to care about this standard. And many of you write software that's bought by US companies too, so this is not so bad. But the reason, and I'm not trying to point to a US standard, I'm just trying to point to some really progressive ideas about password policy. So what do you think is good password policy? The common answer I get today is uppercase, lowercase, number, special character, 8 characters or more. And this policy is bullshit. It doesn't help us at all. Pardon my language. I'm uncouth. I'm sorry. I'll stop. That's my one swear of the day. This traditional password policy is useless. And even worse, passwords as a sole factor for authentication is negligent at this point. If you have a piece of software that saves data about users that's private data covered by GDPR. And you're not doing multi-factor, you're in the world of negligence at this point. I mean that with respect only, because we're in 2020 now. We need rigorous security if we're going to store private, sensitive data or have sensitive features that affect people's finance or health or similar. We've got to do multi-factor. And again, if you're not, negligence. I want you to take that home with you, right? So what is authentication, first of all? We're just trying to establish the identity of an individual user. And how do we manage passwords for authentication these days? Well, let's talk about let's talk about passwords and password storage for a second. The first, I'm going to skip a few slides, but here is NIST really changing their definition of what a password should be. They're saying, don't limit the characters or length of a password except any Unicode character for passwords, including spaces. Your password should be at least 8 characters and support up to 64 characters or more. At the OWASP Foundation, we disagree. Our version of this standard in the ASVS standard, we cite 12 characters as what your minimum password should be today. That does affect usability. But this point is, if you have 8-character passwords and you have multi-factor, and you have all these other controls in place, then 8 characters is just fine. And I think it's a fair perspective. They're saying block characters that contain context words. Here's one mistake I made. This is an older presentation. Please forgive me. I'm gonna do this. So the whole idea of a dictionary word being in your password is completely acceptable. I read the standard when I made this slide. The standard author was in one of my presentations and critiqued me. He said, "You're reading it wrong." So I read it wrong. So whatever. So here we go. We do this again. We got 8 characters or more. I recommend 12. Block characters that contain repetition, many of the same letters or numbers. They're saying blocks context-specific passwords. What company do you work for, API guy?
Redbooks.
What's that?
Redbooks.
Redbooks? So I should never see the word Red Book in a password. What kind of business are you? What do you do at Redbooks?
It's video streaming.
So I shouldn't have the word video, streaming, Redbooks, and similar should never be in the password. Probably pick a couple dozen at most, real obvious context words for your business. The word password is also a bad password because it's or anything including the word password, because that's contextual to the input field itself. Also, check against a list of common breached username password pairs. This is an attack called credential stuffing. There's been, according to researcher Troy Hunt, who's here at the conference, he's real tall, you'll see him, he's here at the conference. He says there's about 7 billion username password pairs in the world today known by attackers. We should be aware of this list, and anytime a user tries to register or tries to change their password with a known username password pair, we should see it in real time and block it. There's a lot of tools out there. There's Troy Hunt's service. Google and Firefox have services out there. It's becoming more common where you can access this data set in your own authenticator. Also, we have to handle brute force attempts. I don't like account locking, because if I know your username, I'll lock you out. I prefer throttling, slow down the attacker in some way. Don't force special character rules, uppercase, lowercase number, special character, throw them away. And that's very controversial, but it's part of the standard. Next, stop using security questions or hints. How do you figure out security questions or hints of a user? So you try to log in as Joe Smith. Yeah, go to, social engineering is work. I wouldn't do that, but it's not, it's a fair answer. Even easier than that. Facebook. What do you think of Facebook, by the way, here in the UK? Is Facebook like a nice, secure service, talk to your friends, or are you posting all your information on a public billboard in your neighborhood? Is that one? It's pretty public, right? Yeah, so let's just move on. No more mandatory password expiration for the sake of it. Anybody work in a world where they have to do password expiration every 3 months or something like that? So, blue shirt man. Hello, sir. Can I call you blue shirt? What does blue shirt mean in Star Trek, by the way? Okay, sorry, okay, let's not go blue shirt. Let's say sir. Sir, when you're forced to change your password, do you use a password cryptographic generator to build a new 40-character random password, or do you take your previous password and increment one of the numbers by 1? It's okay, you're in a safe place. It's a good chance for confession.
I do both.
You do both?
Yeah. Depends on what I'm using the password for.
Okay.
It's
Oh, let's play a game called Security Confessions. It's a chance for both redemption and healing. Who wants to play? Yeah, okay. Who here, when they're forced to reset their password, they take the previous password and bump the number up by 1? Who wants to admit to that? Who here is using who's like, I would never, who here wants to get on their high horse and say, I would never do that. I use a password generator every time, and that's how I roll. Who wants to say that? Like 5 of you. Good, the 5 of you, right here, 5 of you, high five. That's the right answer. As a IT professional in 2020 or beyond, my vote is you should not know in your brain any of your passwords. They should all be in a cryptographic vault, or some kind of password manager that's well vetted in the world today. The biggest attacker of password managers is a Google employee, Tavis Normanley. He suggests to use KeePass, very low tech but great crypto password manager. So your mileage may vary, but please consider that. And also, again, even emoji should be okay for a password. One of the big banks in the US a few years ago, a security researcher was using emoji for her security questions, and it shut the whole bank down. Oops. And so like she's on a support call with the bank, and they're like, are you the person who used emoji? And she's like, why, yes, I did. Poo, 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 smile. That's my password. She's like, yeah, we know. You just shut our whole bank down. Can you please, like, number 1, don't say this on social media? And she's live tweeting the conversation. They just told me not to tweet this. Okay. So yeah, you got to support emoji. It's there. Kids, we're going to use it, so be ready for it. Now, how do you actually store a password in the modern era? Anybody want to play? How do you store a password in your database if you're building your own authenticator? Get the F. Security, NDC security, please remove this person. Now, what's your name, troll guy? What's your name? What's that? Dean? You're such a respectful name for such a troll. So how do you store a password, sir? So you're building an authenticator. The user is registering an account and giving you a password. How do you put that in your database if you care about security?
Hash it.
What kind of hash? If you use, is MD5 the right answer? Is MD5, SHA-1, SHA-2, or SHA-3 the right answer? No. Because any of these algorithms are lightning fast. And for every 5,000 euros I spend, I can do about 2 trillion hash attempts per second. I will pop your password. So if you're using MD5, SHA-1, SHA-2, SHA-3, Whirlpool, you are doing tragically insecure password storage. There's only 3 good algorithms for password storage in the world today. They're hashes, but specialized one. What are those 3 algorithms? No hands raised are ever needed in this room. You just shout it out, sir, because I'm uncouth. That's the one I don't recommend. It's the number 4 on my list. I would only use PBKDF2 if I was building a US government federal system. It's part of the federal standards. It's one of the weaker of the algorithms. And I used to recommend it about a year ago. I just took it off my list at the beginning of last year. So it's a reasonable answer, but it's the worst of the acceptable family. I would keep away from it. I'd use what that bearded guy right behind you said. What did you say? Bcrypt. Bcrypt is the worst of the 3 good ones. It's low memory input, low memory footprint. It's available in every language, and it's a reasonable choice today. And it takes up about like 12K or like 16K per run. And there's a work factor to slow it down. Your MD5, SHA-1, those are lightning fast algorithms by design. Where Bcrypt, we're going to program it to make it slow on purpose. It'll be like a 3 or 4 second delay during login. But if I steal your database, I got to spend 3 or 4 seconds with every attempt, as opposed to 1 clock cycle with MD5. What's a good work factor for Bcrypt? You want to go for double points? You already won the new car. Brand new Aston Martin. We'll drive it up in front a little bit later today. You want to trade that in? What's behind door number 2? Yes, you do. So what's a good work factor for Bcrypt? Hard question. I would use the Hashcat team, the team that wrote the major open source password cracker in the world today. I don't know the answer, so I asked the lead of that project. And he recommended a work factor of 13 or more. And that should be good for the next couple of years because it grows exponentially. 14 is a big hit. One of my customers is a very big bank, a regional bank that rolled out bcrypt and used a work factor of 15, and it like shut the whole system down when they went to production. They rolled it back to 13, and all's well again. Anything below that, a little bit too fast to be effective for security. So I'm going to recommend, again, the family of algorithms: bcrypt, scrypt, or Argon2i, which is default in PHP. Any other algorithm for password storage is going to be a bad idea. Hey, hash guy. Hey, Dean, the hash guy. Before you send any password into ththese functions, hash it first with like SHA-2 or SHA-3, and then send it into one of these algorithms. Because if I give you a giant password that's like 70 bytes or more, bcrypt will truncate and weaken the password. It's also a performance problem. Like if I give you a 1,000-character password and you start bcrypting it, it's a really big performance problem. But I want to support those giant passwords, so I hash it first. SHA-512, 512 bits, and then I shove those 512 bits into bcrypt work factor 13. Now I'm good to go. This is a recommendation by the Dropbox architect PhD, Dr. Devdatta Akaway, in a very famous presentation for 2016. It's still valid even today. And so I'm going to recommend the password storage cheat sheet for more information on this. We have special publication 863.3. I doubt many of you are going to read US standards, but you should read this. It's not just about US standards, very progressive in the world of digital identity. If you're building a login system yourself, it's got a lot of great guidance of modern attacks we see against login systems. Even better, stop building a login system. Don't do it. Use an identity provider. Auth0, Ping, Okta, freaking A. You're likely to have a better security experience with Twitter login as your OpenID Connect login than if you build it yourself. And I'm saying this on purpose to be dramatic, but I mean it. How many hours has Twitter put into their login system? It's got multi-factor. It's got push multi-factor, pretty solid, not even SMS. It's got a push multi-factor. They see mammoth attacks at a nation-state level. Some of it just, I'm going to stop there. But you're probably going to have a better secure experience if you use Google, Facebook, Twitter, or similar login, and an OpenID connector to your app than if you try to write it yourself. And NIST 863B in particular should point you into that direction. Access control, well, let's escalate it quickly, right? A simple note on access control is stop hard coding roles. That's basically hard coding your policy in code. And now I can't do things like data-specific access control. Or how about checking if the user is an owner of that message? So a lot of problems pop up. Like if I see a URL with the message number, like site.com messages 7. How do I steal other people's messages? Just change the number. So I have to add some kind of logic that says only show the message to that user if they're the owner of that message. And role-based access control does not address that at all. So we want to move to capabilities, which has been available in .NET since version 1. We're hard-coding the name of the feature or the data they're accessing and have a rule system in our database to make the call if that could be accessed or not. Roles are quick and dirty, and they work for basic, easy situations, but the kind of complexity before us to do like multi-tenancy, data-specific access control, it all falls apart in the face of role-based access control as a PEP, as a policy enforcement point. We should not be using roles. If they're in your database for grouping, that's fine. Just that roles should never be checked in your code ever in the modern era. Nobody wants to hear this. Who's with me on this point? Okay, let's just move on. And again, ASP roles, we also have ASP claims, where I can hard code the name of the feature and have that point to any additional logic I want it to, like checking if the user owns that data and similar. Yeah, let's move on. So I also recommend you read the NIST standard, the attribute-based access control standard. A lot of the US systems were built with roles, and it broke down in a lot of different ways. So the ABAC standard, attribute-based access control, points us in the right direction to understand modern access control complexity. We also have, in Java, we call it permissions, and in .NET, you call it claims. Please use that mechanism. Here's some resources for you around access control. Let's look at C8, protect data everywhere. How often should we use HTTPS in our work? Is there ever an excuse to use HTTP for anything? No. No. No HTTP for anything. It is a performance problem, and by the way, HTTPS is way more performance friendly than HTTP. Here's some resources on making HTTPS configured properly. Go look at the Mozilla TLS configurator. Pick your server, pick your utility, and it will generate the configuration file for you in every server and cloud service except for IIS, which we shouldn't use. Let's move on. By the way, if you're going to do encryption, you want to use AES. You should avoid ECB mode. You should probably use counter mode for storage. CBC is well supported. You need a unique IV for message. You got to get padding right. You got to get your key storage right. You got to get your process isolations for keys correct. That just gives you confidentiality. If you want integrity, you got to HMAC your ciphertext for integrity or use GCM mode. And you want to derive your integrity and confidentiality keys from the same master key using a technique called labeling. And don't forget to generate your master key from a good random source. And good luck with that. No one gets this right ever, in my experience. I've never seen a hand-coded encryption mechanism that the developer got right. It's too complicated. You should be using something like Google Tink, DAPI, or one of the other well-supported, well-vetted secure coding libraries. I'm a big fan of Libsodium, written by Dan Bernstein, University of Chicago, an activist in crypto, incredibly well built. Also, where do you put your keys? Put your keys in a key vault like HashiCorp or similar. Are you shoving encryption keys in your registry? Stop doing that. You want to use a formal key vault to store keys. So if your OS is popped, the keys are still locked down. Let me jump ahead here. Yeah, do some logging. A couple quick notes on logging. Just log at least 4 events. Any authentication event, any access control failure, any input validation failure, and that alone will let me have enough data to check out what's happening after a hacking incident. The last note is handle all errors. I'll say this, if you're doing REST-based development, you should be using HTTP error codes according to the REST standard. Stop doing that. HTTP error codes are not even close to being verbose enough for good security. I like PayPal's API error code list as a good baseline for financial. Don't be afraid to not do REST perfectly. REST was made in the year 2000 and by Dr. Fielding, and security wasn't even a consideration back then. So I'm going to recommend keeping away from HTTP error codes and instead use your own more verbose error code lists. Don't forget the ASVS standard, the cheat sheet series for additional information on secure coding. Look at the OWASP testing guide to learn how to pen test. And any questions for me, please drop me a line anytime. Wait. Don't use that email address there. Use that one. There you go. Jim@manico.net. It is my great pleasure to be here. I'm over time. I'm going to call it now. Go forth and write secure code, everybody. Thank you for your time today. All right.